Now, in just a moment, we'll be able to get Nishu talking. We're really excited that we have Nishu Goel here with us today, who's got a history in developing things with the likes of IBM and Web Data Works, now at ePilot, and has worked on all manner of different types of tooling and crunching through data and working on optimizations. Now working on various front-end, micro front-end implementations at ePilot. Also is the author of Angular Routing, so a book on Angular there, and has worked with all kinds of different technologies and frameworks and has lots of different insights as a result. She's written interesting things on long tasks and executing long tasks and how we measure those and optimize for that. And that indeed is going to be the subject of this talk, breaking down long tasks. So how are we looking? Are you plugged in and happy? We've got the thumbs up, folks. Okay, please now another giant round of applause for Nishu Goel.
All right, hey everyone, how are we doing? Good, great day, right, so far? By the way, great job, Baz. He's in there, but yeah, I think he's listening. All right, so I'm going to be talking about breaking down long tasks. How many of you have heard of long tasks? Actually, let me rephrase. Has everyone heard of long tasks here? Because this is perf now, right? Almost all of you. All right, so how many of you have experienced this behavior? When you click on something, or your users click on something, and it doesn't respond, or it takes some time, and then you click again because, come on, you want to get your work done. Happens, right? All the time. And this is kind of that interaction delay that the user faces, which makes them click again, right? And then it happens again and again. Now, this is where the browser is actually trying to, there's this visual feedback that's trying to come in, right? And the browser wants to bring a frame that paints it, right? The browser wants to paint it in the form of a frame. Now, the time that the browser takes to paint that frame is where interaction to next paint comes into picture. That's what INP was about, which all of you have heard of, by the way. So that's what INP is. It's a page's ability to assess how the page is doing in terms of stuttering, the jankiness on the page, and so on. Now, this is also a pending Core Web Vital, which becomes official and replaces FID, which is first input delay, in March 2024. So you'd ask me, why does it need to replace FID? I mean, it should be different, right? So anyone wants to answer that? Why would it replace FID? Because FID is rubbish. No, let's not say that. OK, so the idea is FID only measures the first interaction of the page. And 90% of a user's time is spent after the page loads, the first load. So you want to do the interactions, or you want to measure the interactions if you want to get it right when the page has done loading, right? And that happens with INP. INP measures not just the first interaction, but every interaction after that. And then it gives you that worst interaction value, which is where all the interactions are going bad. So according to Web, OK, let's do it again. No. Go back. Yeah. According to Web Almanac of the year 2022, INP does like this. So in the first 50%, it's doing good. 55% of websites have actually a good INP. What do I mean when I say good INP? So there's this range. A good INP is usually below 200 milliseconds or at 200 milliseconds. And anything above 500 milliseconds, it's a bad INP value. And anything in between is a needs improvement situation. So looks like at P75, 36% of websites are not doing well. And with FID, the situation was completely different. I mean, I usually say that I used to be happy when FID was there because there was at least one metric that used to give me that positive feeling that my website is doing good. But OK, let's face reality. So yeah, INP helps in that sense. Now, we have INP, good. We get that value, good. We have that interaction value that tells us that, OK, this is not doing great, and maybe you want to improve here. Let's try again. Yeah. So it gives you that value. It gives you that worst interaction situation, but it doesn't tell you what caused it. And now if you're getting a bad value, you'd want to know right away, what is it? What's causing it? I mean, I did everything right. I'm the best developer, and so on, right? But what if the INP situation could also give you that this particular thing that you're doing in the code maybe isn't that right, and maybe can be refactored or improved performance-wise to just ensure that it's a good INP finally. Now, to do that, we have to do some work. We have to find some slow interactions on the app, right? We have to do that maybe from users' perspective. We could also do that in the lab data, in our setup where we just check on our local, for example, that what's going wrong and so on. But if you do it on your laptop, it's not going to be that close to the user's experience. Like I have a Mac M2, and my user probably has a Windows machine, right? And the gap over there is crazy. So the best bet in this case would be to just go in and try to measure it from the field data. So how would you measure it from there? There's different ways you can do that. You could just go to page speed. That's the first thing that we do. We go to page speed. We try to measure, you put in your URL over there, and you try to measure how the app is doing, how the website is doing, and how do the scores look. But now that's going to be very high level. It's going to give you origin level info, but it doesn't tell you page-wise, right? It doesn't tell you how this page was doing for this interaction and so on. And it's good that it gave you a glimpse of what might be wrong. It might have given you an idea that, okay, maybe the main thread is too much blocked, Maybe there's some script that's taking too much time. But it still doesn't tell you that this part of your code is causing it. And the best situation is when I know that, okay, I wrote this line of code, and maybe that's not too performant, and so on. So we get that glimpse from the first point, which is page speed using, the crux data. But what else? What if I use my own RUM provider, right? People use different RUM providers. We use Datadog at work, and that already does tell us the INP value. It's a chart, which would tell that, okay, this is how INP is doing. Again, needs improvement situation, but does it tell me which part of code is causing it? Still no. So then we come to my favorite part, which is the Web Vitals JavaScript library. And that comes with some information that could actually benefit you and let you know that this particular thing might be the reason that the INP is really slow. This particular thing is the event or the element target that's causing it when you click on it, and so on. So let's get more into that. We want to record something. Now we know we have the INP value, but we also want something else along with it. What do we need? So we need to understand what really do we want to record, right? And that's when we understand that, okay, INP value, first thing, I had it from the other sources as well. In this also, I'd want to know what's the INP value. What else? I want to know what's the responsible element target, right? I want to know that I clicked on this button, and that's when INP went wrong. Right? That's when something happened that the performance just degraded somehow, or it just took forever to load, and we didn't give any visual feedback to the user, and the user kept on waiting, and so on. So I definitely want to know what's the element target on which INP is going wrong. What was the loading state of the document when your interaction was being recorded, the INP was being recorded? So at that time, you want to know the loading state as well. Is it still loading? Maybe that's why there's long delays, because when the first load is still happening or the document is still loading, it could get slow. So you want to not bias the situation and know the real picture. So you would always want to record the loading state of the document at the interaction time as well. What about the interaction start time? It's always a good idea to know what's the, when did you start the interaction? Because, for example, you're recording like a small profile, and it's a click on a button, it's scrolling through the app, and so on. Now, you don't know when was the INP recorded. Was it during the scrolling, or was it during the button click? So if you know that for this element target, that's like a click on the button, and this was the interaction start time, you would have a real picture of what really is happening, and this is exactly when things went wrong, and so on. Now, what about the event type? You would definitely want to know if it's a key press event, did you tap somewhere, or is it a click somewhere, and so on. We didn't also discuss what does INP cover in terms of interactions, right? So it could be a tap event, it could be click, or it could be any keyboard events from, the remote keyboard or the physical one. I think that's kind of understood, right? Yeah. Now we know we want to record this information. And looks like the Web Vitals JavaScript library is going to help us with that. So let's look at that. OK. No. Yeah, good. OK. Yeah, this is going to be a struggle. But yeah, so we noticed that we had this other way of also recording INP or any core Web Vital. In this case, it's Datadog. This is what we use at work, again. And I recorded the INP for our own website, what Datadog recorded. And it falls somewhere here. So it needs improvement in a way. And this is how it would look on your provider or anywhere. But now, again, in this graph, it does tell me that this is the INP situation, but it's not telling me that this particular thing caused it. So I would still want to go to my favorite part, which is the Web Vitals library that causes it. So, OK. Sorry. Yeah. A bit laggy, but it's OK. OK, so yeah, great INP value. I mean, not great INP value because it's in the needs improvement situation, but we don't know what's causing it. So let's move to the next part again. I think I'm going to just use this instead. Would be much better. Yeah, so we are recording now using the Web Vitals JavaScript library. Now, I say that we need the attribution build. Does anyone want to answer why we would need the attribution build? To make the bundle larger. OK, OK, good one. What else? OK. Yeah, so the idea of using the attribution bundle is exactly because we want more information from it, right? We don't want only the INP value, but the diagnostic information as well. So if you import it like this from the attribution build, it would cause some problems in the sense that it makes the bundle larger, but it's only 600 bytes. So you're adding something here, but it might end up helping you in so many other places by actually letting you know that these are all the places where your INP is going wrong, and this is where you could fix it. So the build is 600 bytes larger, sure. The build is broadly compressed. I mean, if that makes the statement better, that it's making the application larger. So you could import it from there, and then it comes with some information that would really help you then. So this was how the INP metric looked earlier, and then you add that extra value with the attribution build, which is that attribution property, and that includes all of these fields that you might be interested in. It involves the event target, right, which was what one of the things that we wanted to record in the things to record. Then it includes the event time. It includes the type of the event, again, the tap and key press and so on. It also includes event entry. We'll look more into what event entry is. And then the load state. Loading state, again, is the situation where you want to see if the document is still loading while the INP was recorded, or is it already loaded, and so on. So what is event entry? Yeah, it was moved. So these are the values that you can get from the event entry. It could be different timings, like the startup time, the load state. Load state was already there outside the event entry. Processing start, processing end, and so on. So this is all the durations that you might need to have a proper understanding of how INP was recorded, when was it recorded, and so on. And then you could just send this information to your analytics tool or something. You could just log it, but it's always a better idea to just send it to your analytics tool. So you just record it from there. You can maybe visualize it later and then see the final picture of how INP is doing on your application in the field. This is not lab data, right? Because now you're getting it really from the users. So once you do that, can I just click over here? Yeah. What could go wrong? What could happen with INP recording? What if the INP value is not there at all? Is that possible? Or the event target is not there at all? That's kind of possible, right? So what if I use micro frontends at work, and there's a lot of detaching of nodes and attaching of nodes all the time. So it could very much happen that when the INP was recorded and we were trying to capture the event target, it was null, right? Because it was maybe detached from DOM, or maybe you were using shadow DOM, so it doesn't even capture from inside shadow DOM, and so on. And in those cases, the event target value would be empty, but we know why it would be now, right? So Now, we have the field data, we have INP value, we also have diagnostic information with it, but what next? What do we do next? We got it from the field, now we have to reproduce it somehow on our end, right? We have to somehow try to fix it. So that would be next. Yeah, that would be next. How do we reproduce and fix it? So to do that, we found slow interactions on the app somehow, but that's when comes testing in the lab, right? You want to see and you want to reproduce it. However, if you were like me, you'd just say, let's go to the performance profiler. But you know how overwhelming it can get sometimes, how intimidating it can get sometimes. And maybe let's try something low effort. Let's try something that doesn't lead us directly to the performance profiler, and then we have to see those long tasks and huge, so many tabs and so on. So there's this Web Vitals Chrome extension that you could use. And it would look something like this. So you'd have to enable logging, and then it would give you some information like this, which tells you that, OK, this is the INP value or situation, that it looks good, it looks bad, and so on. And these are the different interactions happening over there. Let's actually try to enable logging from the browser. Not sure how many of you have done that before, but it would be a good small activity. So there's this dummy application. Or dummy page on the application, wherein, let me know if I need to zoom the DevTools a bit. Would be good? Let's do it. OK. Yeah. So now, first, let's just close it. Yeah, I'm going to reload the page. And I have this Web Vitals Chrome extension already enabled here. You could just download it, install it. And then there's this settings icon over here, where you could enable console logging, and then you save your options. Also, if you're interested in any other options, that. And then, now let's close this tab. Let's open the DevTools. And I expect that I see all that information in the console now. So let's interact with something. I've already filtered for INP, by the way, in the console. So I'm only getting that information. But let's get rid of that for once. So you would see I'm getting everything from Web Vitals extension, the interaction, time, and INP time. There should also be other core Web Vitals, CLS, LCP, CLS, and so on. Yeah, so let's filter for INP in this case, and let's interact with something. Yeah, so it tells me that, OK, this is the INP situation. And now if I zoom this, it tells me the event target element that could be causing it. It gives me some things that are happening. The input delay took 1 millisecond, for example. The processing time was the most time-taking thing, 81 milliseconds. I mean, the INP is still good, but I could question why is the processing time, in this case, 81 milliseconds. I just clicked on a small selector. And then the presentation delay and so on. So these are the information that could really help you to understand what's going wrong in this case, right? What's going wrong to measure INP or just with your application in general. Now, let's go back to the slides. So it's going to be here. Yeah, we already saw this. But now, we use an extension now, right? What if we cannot use that extension? Or what if you want to simulate the experience on a mobile phone, right? You can get the DevTools. You'll have to connect it to your machine. But yeah, what if you're doing it on an incognito browser? So there's this piece of code. It was a small detail. There's this piece of code which does exactly what the extension was doing. So yeah, just use that in the console, and that would give you exactly the same logging, which would, yeah, it might not be much visible, but you know what it was showing. It would give you the element target again. It would give you all those timings that you need, and so on. So yeah, it also solves that problem of trying it on cognito machines or browsers or just some other machines. Now, at this point, you would say that, OK, I also tried to get it from the lab data, right? I also tried to get it from the console. It still doesn't clarify what exactly it is. That's when you'd finally go to the performance profiler. Let's do it. So you go to the performance profiler, and OK, intimidating, right? Yeah. So I see that there's some little red triangles on the top right, which we now, I guess, at Perf now know that this is a long task, right? And This long task could be caused due to anything. At this point, I'd question: is it is it some third-party script that's bloating the main thread a lot, and that's why the main thread is busy? Is it some expensive event callbacks that are causing it? What is it? So at this point, to understand that, let's see, first of all, one example of a task, right? So this looks like a blocking task. It's taking more than 50 milliseconds. What exactly is a long task according to you, by the way? Something that takes longer than it should, right? There could be some expensive task. They have to do the job that they are doing. But there's something wrong if they're taking more than it should need. 50 milliseconds for a task. What if you could break down a task into smaller tasks? What if there was one activity that one task was doing, and the same part in the same method was done into another task? That would not block the main thread. That would at least allow the browser the space, or the main thread the space, to understand that, okay, this task looks like I can do it first, but it needs to prioritize those. It's just that we have a little more room now to play around with those chunks of tasks instead of this one long task that you see here. And that's where you would see that, okay, you would think that, how do I tell the browser how to prioritize the task and so on? So we already discussed this, right? It could be expensive event callbacks. It could be an input delay, and so on. The clicker is working now. So yeah, how do you tell the main thread that there could be something prior? Scheduler.yield. So you would want to yield to the main thread. What does yielding to the main thread mean? You want to let the main thread know that there's something more urgent. Do that for now, and then continue with what you were doing. So the yield API would do exactly that. There could be your own yield method, which just uses a set timeout, right? That maybe has a promise that resolves on doing that set timeout. And that simply puts the action into a different task. And then the browser has the ability to prioritize it and so on. Now, this is in origin trials right now. You can access it from there. Good idea to just access it, try and give the feedback to the team. But yeah, that's what scheduler.yield does. We'll talk more about it in the latter parts of the talk. But how does React do it? Because you'd ask me that I don't want to use that vanilla stuff, right? I just want to do what I do in React. So Start Transition API actually allows you to do that. Now, there's a difference in the understanding. With yielding to the main thread, we were telling it that there's something more important. React does it a bit differently. It classifies urgent and non-urgent tasks. Everything is urgent by default, by the way. But if you want to say that something is non-urgent and can be dealt with later on, you would just wrap it in a Start Transition API. They also have this use transition hook, I think, that does the same thing, and which basically exposes the Start Transition API. And then you could just use that to wrap a method inside that Start Transition, and then that kind of becomes non-urgent. That can be dealt with later on. How does React do it? It gives back the control to the browser every 5 milliseconds, so that the browser knows that it has something to do. Yeah, so that's how React does it. Now, this was the input delay part. This was the expensive event callbacks that we were dealing with. But what if it's the rendering part that takes most of the time? What if big DOM size? I think most of our applications have this problem, right? We have bigger DOMs. We have so many elements. I think it's the framework industry that made us do that, ultimately. But yeah, so that's also called the presentation delay, right? And your applications could look like this. I mean, I regret saying that, but mine looks like this, kind of. So yeah, this could be so many divs, and all of this tree situation. And that's what leads to style recalculation. I'm not sure if you noticed earlier in one of the screenshots that I shared from the DevTools, the profiling section, where it said recalculate style. Right? And that's one of the most common issues in the profilings that we do. At least in most of my profilings that I do, I always see recalculation of style. And that's because the styles have to travel up the tree, and the tree is so big. What could you do to help this situation? We already use fragments, right? So that's one way to solve it. But the idea is to just keep it simple, just keep it small, do as little work as possible. Yeah, so style recalculation could be kind of fixed by having a smaller DOM tree. What else? Forced reflows. Okay, clicker. Yeah, so there could be complex CSS in your application as well. And now imagine doing this with a simple CSS. The browser would have to do a lot less work. But in this case, the browser has to understand and like find in the DOM tree which one is the element which has this class, the dot title class, and which has a parent of this particular class with that particular child and so on. Now, this is where the browser could also take so much time because it has to do all of those calculations. And the idea would be to keep the CSS maybe simple, not that complex, for the browser to avoid having to do that much work. So that's going to be forced reflows, and that's going to help in your presentation delay if you try to avoid something like that. Yeah, so this was the long task situation, what we looked at. Now, what are the problems with long tasks in general? Has anyone already tried to use long tasks and saw that it was not that helpful because it was not really giving you the right picture? Happens, right? So it tells you that a long task has happened in the, and it took this long, but it doesn't tell you, again, that what really caused it. It's that, high-level event container that might have caused it. But again, it doesn't tell you that this particular function or script was the one that caused that long task. Also, it doesn't count that rendering update, that presentation delay later on. So it happens in a different task, and it's not included in the main long task measurement. So again, it's kind of not close to what you would want to have. And already, because there was feedbacks from schedule, the origin trials and so on, there was an improvement on this while we were still understanding what long tasks are, and that's long animation frames. So that kind of does the same thing. It has the same threshold of 50 milliseconds, but there's one difference. It doesn't measure tasks. It measures frames, and that could include so many tasks in themselves. And now the idea is to measure frames instead of tasks. Right? And that frame could include one whole activity in itself. It would also tell you that this particular thing was in that frame caused that delay or something. And how does it do that? It has a better attribution way of doing it. So it tells you exactly the properties that might be causing it. It tells you the name. It tells you the type of the event, so that's quite helpful, right? It would tell you which event type it is. It would tell you all the kind of timing data that you might need. Start timing and how long it took, when it ended, and so on. And then the window attribution, which is not the up-level window container, but exactly what might have, where it might have happened. So that's better in terms of understanding what might have caused the long task, or let's say long animation frame in this case. And how do you enable that? So you might have done that before, right? Experimental web platform features. So you just enable that to be able to access the API, which is the long animation frame API. And again, this is in origin trials right now. I was looking at how to pronounce this. Is it LOEF? LOEF? It was written on the blog, but I couldn't figure that out. LOEF. Let's see what the Google team has to say. But yeah, so you could enable it on the origin trial and explore it again. So it would be a good idea. There's already one good case study from RumVision, I guess. Actually, the team of Erwin, they tried it, and they used the long animation frame API. They could figure out some third-party script that was causing the slowness for them, and they could actually figure that out. So they tried to, they went to the application that was causing it, and then I think it was Moment.js eventually, but the team can tell you more. But yeah, so it's been helping people already. They are recording it. They are trying to find what's that script causing it, or what's that piece of code that's causing that slowness. So yeah, that's how you would enable origin. This is how you can enable origin trials. And the result could look something like this. So this is definitely more information as compared to what you'd get from the long tasks API. And so it fits everyone's separate use case. You decide what to do with what information. I think I would use the element target and the timings a lot. But yeah, let's give feedbacks according to how it helps. So we saw earlier the scheduler.yield method, right, which allows you to yield to the main thread, which lets you let the browser know that, OK, this is where you prioritize something else and so on. But there's different strategies. You're telling the browser that, OK, prioritize at this point. But do you even know when to prioritize? I don't know. I don't know that at this point of code, piece of code, I want to say that, OK, browser, just prioritize it. Not that simple, right? So this was the main method that I was talking about. If you don't have the scheduler.yield API, you could just do something like this, and then it would put that task in a separate thread, in a separate task, and then prioritize it if you want to, but it just chunked the task. It just made that long task into 2 smaller tasks now. So the other way is scheduler.yield API again. The problem with the previous way was that if you're prioritizing something, you would expect that this is prioritized, but rest everything should be continued the same way, right? The priority should be the same as it was. But that's kind of not what happens. What if there's another event source, right? What if there's another click from the user that happens? Would the browser prioritize that or the things that were already in the queue? So the problem is, with this particular thing, with this set timeout way of yielding to the main thread, it pushes everything to the end of the queue. And that's taken care of at the end when the main thread is completely idle, maybe. Anything that comes in between is tackled first, and that could lead to inconsistencies, right? You wanted to deprioritize some stuff, but not maybe towards the end of the queue. That's kind of not what you would want to give the user the experience of. So scheduler.yield API tries to do that. We already looked at that. It tries to combine both of those, which is also being able to defer, right? Also being able to yield to the main thread, not defer, but yield to the main thread, but also at the same time, keep everything in the same priority as it was. If something was before in the queue, it should still be before, and then anything that comes after that should be tackled afterwards. So that's scheduler.yield way of doing it. But you'd ask me, what if I could just prioritize them? What if I could just say that this task seems more important, but this one can be tackled after this when the main thread is a bit free. And the last one should happen completely in the background. I don't care. It's completely an asynchronous way of doing it. Whenever you have time, do it. I don't care. It's not going to be visible to the user and so on. So there's actually priorities that come with it. This is, by the way, just a screenshot of the scheduler.yield origin trials if you want to apply for those. So scheduler.postTask API allows you those priorities. And it would tell you that, OK, you want to prioritize something for the background, which is like the least important. You just give it the priority background, and then it would just do that in the background. What would be the most important? User blocking, right? Anything that the user is waiting for. It might not be a successful acknowledgement that, OK, whatever you were trying to do by the click of that button is done, but it can be some visual feedback. You maybe want to just show a spinner, right? You maybe just want to say that, OK, this task has been aligned or queued or whatever, but we are working on it. You don't have to click twice or thrice and so on, right? So you're giving some visual feedback to the user. And this is how the priorities would work. So user blocking blocks the user, so that's the first most thing. User visible has to happen, but it doesn't have to go to the end of the queue, but still, do it after the user blocking tasks. And then there's background, which can happen anytime, and you don't, really care about that. Now, again, this involves more work from me. I have to say that, OK, this is when prioritize it like this is when prioritize it like that, and so on. What if you could just tell the browser, do it when you think that the user needs some feedback, right? Do it when you think that the user is waiting for an input. And that's what isInput pending API does. So this was from Facebook and Google that they introduced this API, navigator.scheduling.isInput pending. And the idea is exactly that. So you would only prioritize, or you would only yield when the user is actually waiting for an input. So it would return a Boolean value saying true. Now the user is waiting for an input, right? And the way it works is, I think it looks for an interaction within a frame of time. And if there has been no response to that interaction, that's when it would say, yeah, that the input is pending. And that's when you would want to yield. So that kind of takes some task away from you. You don't have to decide what's more important, what's less important, but the user kind of decides for themselves, right? If you see that the user was waiting for something, or if the browser sees that the user was waiting for something, the browser decides to prioritize that particular task because that seems more user visible or blocking. This is kind of the way it does that. So, if the is pending value returns true, right? Or because it's not available in all the browsers, there's a hack also to do that, which is you just, OK, that's kind of cut. But yeah, you could calculate the performance right now and then subtract the performance from the 50 milliseconds from it. I guess it's 50 milliseconds. the threshold. Yeah, and then you would do a set timeout, which would then put it in a separate task and then yield to the main thread. So that's the is input pending way of doing it. Now, yeah, let's go to the recap. So we looked at how, first of all, INPs work, right? INP works. We saw how it could you could yield to the main thread. We saw how it gives good attribution now, right? You could also diagnose some information. It's not just one INP value. It leads you to measure field data, right? It gives you the ability to measure field data using the Vitals, Web Vitals JavaScript library. You could then use the lab tools to kind of try to reproduce it first without the profiler and then maybe with the profiler if that was not that helpful. You now know what could be the different delays in the browser, right? You know, you can maybe read the long tasks a little bit or the long animation frames now a little bit. And then finally, we talked about the strategies to kind of let the main thread know that maybe prioritize it, maybe deprioritize it, and so on. So yeah, that's basically it. And that's how long tasks kind of work. I would, in the end, just thank you.
Awesome stuff. Thank you so much. Come and join me on these ludicrously tall stools. That's fine.
Let's try to sit. Okay.
Okay, we made it. We made it. Thanks for such an interesting talk. It's so fascinating to see some of these tools that I personally don't spend so much time in, as many as so many of the people around the room, I think, do themselves. I'm curious about the type of events. You're talking about interaction events, and you did mention like a bunch of different types of events. Do they have much impact on the measurements you get out of there? I mean, so for instance, do we see different characteristics for coming from events that are triggered by click versus tap versus drag versus? I mean, I guess lots of these events are kind of compound kind of things anyway. But do we need to take that very much into consideration, or is it purely as simple as something is initiated something, and then we start measuring?
Yeah, that's a good question. I didn't think of it this way. So you're saying, for example, if the user tabbed, is that more expensive than if the user would have pressed a key on a keyboard?
Yeah, exactly that kind of thing. Because I think there are, if I recall correctly, I know there are particular characteristics of what constitutes a tap versus a press or what have you. I'm a bit ignorant of this part of the world. Yeah,
I think the way I would think of it is that what really is the work that you're doing on that tap. Right? If that tap is making you do a call to the backend, get some data, also render it, and then also give the feedback to the user, that tap is going to take some time, right? But if a key press, for example, is just showing a snack bar saying that, okay, this is done, then it's going to be quicker. So I guess it might not depend on how a tap or a key press event would, differentiate in terms of how much more expensive what is. But yeah, I really think it just depends on what task you're doing behind the hood.
The actual work that's happening, which I guess is what the point is in the first place.
Yeah.
You also mentioned a little bit about breaking longer tasks down into shorter tasks, and I kind of imagine that there are implications for like the perceived performance if you do that as well, if you're breaking down longer tasks and then, I don't know, gradually displaying things to the user over time or what have you. But if lots of tasks are associated with one particular action, are there ways that we can break a longer task down into shorter tasks but then still associate those or can visualize those together? Is that purely down into the job of the tools that are visualizing these bits of data in the first place, or is there anything we can do to help us with that?
Yeah, I think that's why it really depends where you're using this yielding to the main thread, right? Because there can be tasks where you cannot give a feedback before the task is done, right? You cannot say that, okay, I've done something for you. It's happening in the background. No, the user's not looking for that fake feedback. So I guess it really depends, again, on the task that you're doing. For something that can get a visual feedback, like send to the queue, then it's going to show you a loader. That's good enough. I've gotten some feedback, and rest of the stuff is happening. But for something that I click on, for example, a table, and I want to load an entity based on that, and if I see some feedback that okay, we are loading your entity, maybe that's not that promising, because you want to see the entity right away. So. The way you perceive it would really depend on if the deferred task is kind of making sense also to the user.
Yeah.
It's not just because you want to give some visual feedback. It's also because it makes sense in that place to give that visual feedback, but not just to share something with the user.
Sure. Yeah. I also had a question. Maybe this is unfair because maybe this is more of a human thing than a technical thing. But was just thinking about when is the best time to be doing this kind of testing and monitoring. I mean, you showed really nicely how you can be using different mobile devices, and also how you can be gathering data from real users. I wonder. Sometimes it feels like we measure things while we're doing it, right? So as we're building something in a development environment, and you also kind of called out the capabilities of your development machine over there versus the things that we have out in the real world. Do you think it's as valuable to be testing these things and trying to optimize during development, or should we simply wait until it's out in the wild? And do we even ever get a chance to revisit it then?
Yeah, that's a good question. We've been thinking a lot about that at our work as well, because it's difficult to make every developer performance mindset, because they don't want to. They just want to push something. They just want to have that feature up live. So we've been thinking of several ways of doing it. So every time a feature goes up live, right, you deploy it. There should be we were thinking at work that maybe there's a pipeline that kind of blocks, and we already have this channel which is called alerts performance, and that tells us every time a long task went beyond.
Nice.
It became a long task basically. So it tells us that for anything that's every time a feature is pushed. So that's one time that you would want to do it. You don't want to do it actively when you're developing,
right.
But maybe finally when the feature is up there, and maybe in a canary situation or something where you are now measuring how the performance seems.
Sure.
Has it degraded after that new feature? Did you use something that might have brought it down? So I would say that's maybe one place or situation, that's where you'd want to do that. I still find it really difficult to make everyone performance mindset. It's so difficult even at our work. There's this two people who are always focusing on performance, but then rest of the people are like, okay, let me just push the feature. So yeah.
I love the idea of being alerted to these things that are happening out in the real world when some of these signals are detected. And talking as well about how we visualize some of these things and report them. There was a question that Stuart asked about Google Analytics, and I don't know if you know this or not, but he was wondering if there are any tips about how to get Web Vitals recorded in Google Analytics 4 now that I think some of these performance aspects have been removed from Google Analytics. Have you got any tips for how to get these things visualized there, or should we be talking to the folks from Google around the room?
Yeah, I guess so. I've not used Google Analytics before, but the other example that I was showing using the Web Vitals library, which would give you a metric like on INP, right? And on that method, it would give you values like attribution, interaction ID, and so on, and that you could just send to Google Analytics. I don't know how to visualize it over there in Google Analytics. That maybe someone else can answer better. But yeah, we can definitely send that information.
Yeah, cool. And there was another question actually from where are we? From Aaron, who was talking because you mentioned about the impact that the size of the DOM can have, and a few other aspects as well. And Aaron was wondering about CSS containment and whether or not the different aspects of or the approaches to encapsulating CSS could impact on there. Are you aware of big impacts that can have?
Yeah, I guess I've heard a lot from different people. We even tried it in one of our micro frontends. That CSS containment was really helping a lot with, just drilling, bringing down the INP, or just making it more performant. So you have to try different ways, but CSS containment in general is a really good idea, I guess. We have tried it at work. That helped us. People are using it as well to just bring down INP. So yeah, definitely a good idea to try CSS containment for that. Yeah.
And I guess really my final question is, can we not just keep some nice metrics that we can hit, that we get a nice green check mark from straight away, so that's just nice and easy? Because I think that will encourage us to pursue the other things as well. So at the very beginning you were talking about, it's kind of nice to have some of these metrics. Yeah. I'm for that. Can we just not have some of that? Can we get that?
Yeah, I mean, as a developer, I'd just hack it from DevTools, make it green looking.
Just sending, it doesn't matter what the numbers are, send them back green. Brilliant. I love it. Okay, brilliant. Well, I think we should let you go. Thanks so much for answering the questions, and thanks for your wonderful talk. Please, everyone, a big round of applause.
Thank you very much.
Nishu Goel. Thanks, Nishu.